Hello everyone, my name is Timothy Warner. Today is April 21st, 2019, and we are showing off a little path planning and simulation today. For this, we're going to be using Matlab R2018B and Vrep, and then to control our little robot, we're going to be using a Matlab API. If you haven't seen how to set up the Matlab API, there will be a link in the description down below. That links you to another channel that helped me set this up, and it's really quite easy, so you should try this yourself if you're not already doing it for the same class that I'm doing it for. So today we are going to be trying to get this little Turtlebot over here. This is the Turtlebot 2 somewhere over here, and the map that we are using is the University of Maryland at College Park's Robotic Research Laboratory. And we'll be using a A-star planning algorithm in order to figure out what's the best path to get on over to our goal position. So let's just go ahead and jump into it. We'll start our Matlab program. And the first question that pops up is, would we like this to be a point robot? So if you're not familiar with what a point robot is, it basically means that we're going to shrink our robot down to a single point. And we're going to make all our objects slightly larger by about the size of the radius of our robot, plus a little bit extra to make sure we don't accidentally crash into something. So we'll go ahead and say, yes, we want this to be a point robot. It will also solve out a lot faster. Then we're allowed to put in two different speeds. This will be the two different speeds in RPMs that the robot will be able to operate at. Not necessarily saying that left speed is going to be 10 and right speed is going to be 40. This just means that the robot can move at 10 RPMs or 40 RPMs, and then there will be an action set that will choose either of those RPMs from. We're going to go ahead and keep it at 10 and 40, simply because we've done a lot of different trials to make sure that this one works for us. And then our robot starting position. Now we can place our robot anywhere we'd like so long as these numbers match up with where our robot is. I've gone ahead and placed our Turtlebot 2 at 1, 1, so we'll go ahead and keep it at 1, 1. And then our end goal position is going to be at 9, 5, so that gives us a nice little challenge to get on over here. And boom, we have our Matlab representation. So we have our point robot down over here, and we have our goal position over here, with this little square right here being an area that says, hey, if we get there, we should be pretty good. And then as we can see, all these objects got pretty big, or at least a little bit bigger in comparison. They're all about 0.357 divided by 2, which is the radius of the Turtlebot, plus a little extra, I think it's about 3 centimeters off, just to make sure that we're not going to smack into anything. So we'll go ahead and launch us into our main loop. Now this should only take a couple of seconds since we're running it as a point robot, and we're not going to be plotting anything until we're done. Oh, look at that. We're already done. 9.67 seconds. 66 seconds. So we'll go ahead and launch that. And then when the blue shows up, these are going to be all the points that we visited. And then this is the path that our robot is going to be taking. Look at that. We reached our target location. And then it will output a file, or really it's not going to be a file, it'll be a variable that we'll use in our Matlab API that has the theta, the right speed, and the left speed, or the left speed and the right speed. I forget which is which, though I've got them all sorted out in my API. So we'll go ahead and move on over to the API. If you don't have this set up, there's a link in the description down below that links you to another video that helped me set it up. I think it's by Nikolai. He is super helpful with his video. It's very straightforward, and you'll have it set up in no time. We'll then stop the simulation, pause it for a second, and start the simulation just to make sure that everything is all set up correctly over here. and then we'll go ahead and grab all our objects that we need to in order to move around. That's mainly going to be the wheels and the target velocities. And then I was trying initially to set up like a feedback loop where I would get the object position on the object orientation in order to make sure I was facing the right way and getting to the right location. The problem is that the orientation is done in Euler angles, and if you look on over here, I get my angles in terms of degrees, and they're absolute degrees, so unfortunately it didn't quite work out. Maybe for another day, but we're going to go ahead and launch it without it. It then assigns the left speed and the right speed from a for loop that will go through as many steps as there are to get from here to here. If I remember right, it's going to be about 56 steps. And then in order to get to our location, we're going to pull the time, because Vrep's time and Matlab's time are actually two very different times, so we need to make sure we're on the same level. And then I'm also doing some scaling because there's still some issue when it comes to using while loops in Matlab for Vrep. And then we'll go ahead, once we enter in here, to set our left speed and our right speed, and we'll continue pulling the simulation time until our simulation time is not less than our simulation time step. And then once we've gone through that, we'll stop the vehicle and make sure that we don't have any extra momentum. And once we've exited this loop, we'll stop the vehicle, we'll print out our goal location, where our bot actually is, and we'll be able to compare and see just how close we got. Hopefully, we should be about maybe a robot size off, so about, what is that? About 4 centimeters? No, 0.4 meters. I forget what the translation is. So we'll go ahead and run our Vrep API. Now this part's going to be a little bit slow. Oh, look, 54 steps. Simply because we are not moving at such a high velocity. But there we go. We got our little Turtlebot moving around. We'll go ahead and bring up our figure just to make sure that we can see that the path that it's taking is pretty much the same path that we're looking to see from our little Turtlebot. So it looks like we might be a couple degrees off here, simply because we're starting to move up the Y location as opposed to what it shows over here. And we should end up somewhere about right over here is where we're trying to get to. Look at that. Pretty darn close. So we were trying to get to 9.5, and then we had about a 0.5 radius off. So we're looking at pretty close. We're about a meter off from, in the X direction, from where we wanted to be. So I think we can call that fairly successful. Well, thank you for watching. Stay tuned for more robots on my channel, or whatever the heck I throw on up there. And thank you, and have a great day. Bye.